Start.
Okay, thank you. We're live. Oh, okay. Sige, promote kasama. Rodney Dayoan. Rodney. Promote the panelist. Promoted naman. Cherry, how about your students? What are their names again? If they're in, I can promote them na.
I will promote them. I promoted them
Okay.
earlier,
Okay.
but they were
Okay.
demoted. So that I'll do it.
Okay. Okay.
Can they participate? Well, when you ask questions to them, can they like talk or they just have to listen?
We have a Q&A button in the Zoom, so they can ask it. But if ever they would like to express it verbally, we can elevate them as panelists.
Good morning, everyone. How are you today? I hope you are doing good, doing better, better than good, and amazing. Welcome to the second day of our fourth Information and Communication Education Conference of the Computing Computing Science of the
Society.
Philippines, SPICE, and ICE 2021. I am Dave Marshall, and I'll be your host for this day on the second day of the CSP-ICE 2021 conference. This conference is hosted by Southern Leyte State University, and of course, we are live, and at the same time, we are on Zoom and live also on YouTube. But we encourage everyone to participate by joining in Zoom. The registration, I mean the link, the Zoom link is available at the CSP Facebook page so that you can participate with our invited guest speakers for today. For today, we divided our session into two major activities or session for this day. In the morning, we invited two amazing speakers, no, to help us and to guide us and to learn more about information and computing education. And in the afternoon, we will have our interactive and consultative discussions on the BS in data science. So I hope you are excited because I am so excited also. Although we are online, we are on the cyberspace, but I believe this platform will still give us connections and give us the the courage, no, the same like in a face-to-face conference. Without further ado, let's have our opening prayer and our national anthem.
Dear God, thank you for the opportunity to meet together. Please help us to come together to make this institution reflect your kingdom. Breathe life into our ideas and decisions. Help us build a team that has love and respect at its heart. Give us the strength to continue working for your kingdom in this time of pandemic. Lord, come give us the inspiration to be the best we can be. May we be a shining example of your goodness and truth within, wherever we are. Inspire our thoughts, discussions, and ideas, and continue to remind us that all that we do here today, all that we accomplish, is for the pursuit of truth for the greater glory of you. We ask these things in your name. Amen.
To give us the review of day one, let's welcome Mr. Kent Levy Bonifacio to give us the recap of what we had done yesterday.
Good morning. Am I audible na po ba?
Yes, sir.
Okay. Okay. Maayong adlaw sa tanan. We still have a lot of research and information ahead of us today. But before we start with today's anticipated keynotes, let me give a brief run-through from yesterday. The fourth Information and Computing Education Conference was opened by one of the SPICE advisors and our very own Dr. Randy Gamboa and Dr. Pros I.D. Yepes, the Southern Leyte State University President, and of course, our conference chair, Dr. Greg Victor Gabison. The first keynote was given by Dr. Erica Ligara from the Asian Institute of Management. Dr. Ligara presented the capabilities of AI as a nation-defining instrument. Dr. Ligara also pointed the challenges, the applications, and the collaboration opportunities in the industry, academia, government, and society in the field of data science and artificial intelligence. Dr. Ligara also presented the pillars, strategic dimensions, imperatives, and tasks of the National AI Roadmap. Also, the National Center for AI Research Outlook in the country and its priority research programs in the field of agritech, aquaculture, transportation and urban science, smart manufacturing, healthcare, and resilience technology. Dr. Ligara ended the talk in pointing out the possible implementation of data science research with partner agencies in both government and industry parties. After the first keynote, our very own Dr. Jaime Caro, the CSP's Vice President, spearheaded the business meeting. The business meeting concluded with the election of the new board members that will continue the objectives of the organization in the succeeding years. The afternoon's keynotes are the series of presentation of course exemplars relating to artificial intelligence, data analytics from Centers of Excellence in Computing in IT institutions. The first talk was delivered by Dr. Val Randolph Madrid of the University of the Philippines, Los Baños. Dr. Madrid talked about the computer vision as a tool in agricultural and environmental research. Also, the process involved in data analytics from data pre-processing to come up with a prediction model. Dr. Madrid shared the applications of computer and machine learning to create research tools that was developed for coral reef mapping, capturing of different eggplant varieties for genetic analysis and wood identification for foresters. The course exemplar in natural language processing was presented next by Ms. Angelica de la Cruz of the National University. Ms. de la Cruz introduced us to the language processing applications such as machine language translation, language identification, speech recognition, chatbot, and sentence analysis, to name a few. Ms. de la Cruz also pointed the challenges in NLP and concluded the talk by giving presentations in preparing an NLP course. Ms. Marisa Buchanan from Linux Corporation presented the third talk of the afternoon. Ms. Buchanan introduced AI-related projects of the Linux Corporation and presented course exemplars for intelligent systems. Ms. Buchanan also imparted their application of backwards design approach in achieving an outcomes-based course. The speaker also sampled an implementation of HRD in Moodle for student interaction in the flexible learning. The fourth talk was presented by no less than Dr. Maria Mercedes Rodrigo of the Ateneo de Manila University. Dr. Rodrigo presented a talk titled An Intro to the Intro to Data Pre-Processing. The talk emphasizes on the significance of data pre-processing in data analytics program. Dr. Rodrigo cited the importance of the course and presented how this course can be carried out by educators. Dr. Rodrigo ended the talk with a noteworthy discussion on the appreciation, of data pre-processing to come up with a robust data set to produce a good model. The last talk was presented to us by Dr. Chris Jordan Aliak of the Cebu Institute of Technology University on the best practices in teaching AI. Dr. Aliak started the talk on the detailed introduction of the artificial intelligence landscape and presented the course implementation of CIT in AI. Dr. Aliak also presented the different topics in learning outcomes in the field of robotics, problem formulation, image processing, and game theory and their symbolic learning. At the end of the presentation, Dr. Aliak also provided an insight in teaching artificial intelligence. That is to inspire, to demonstrate, emulate, create, and to have an outcomes-based assessment of outputs. Yesterday was indeed packed of relevant information for us moving forward with the AI roadmap. We hope that you will learn more and enjoy the second day of the conference. Thank you, and again, maayong adlaw sa tanan.
Thank you, Sir Kent. And indeed, yesterday was a full pack of new learnings, perhaps, or additions, especially in our new modality of teaching and learning on the flexible learning. As they say, data is the new science, and that's basically our theme for the day. As we will be hearing our speakers and paper presentations, and then in the afternoon, we'll be talking about data science. Without further ado, let me introduce to you our first invited speaker. Our first invited speaker, with over 25 years of technology experience, he has been creating, delivering, and implementing business transformation solutions aligned with business strategies and objectives, improving business performance and revenue generation. He is highly accomplished in conducting research, building technological architecture, product and business development, and delivery. In addition, our first speaker for today is passionate about managing teams and providing targeted training and development for optimal employee performance and increased productivity. Our speaker has technical proficiency in cloud-based services, over-the-top OTT media services, systems and network administration, database administration, data analytics, object-oriented development, and agile development practices. He has led successful critical digital transformation project in top enterprises worldwide. And take note, including ABS-CBN, Z Media Corporation Ltd of USA, Microsoft, and Colgate Palmolive. Friends, ladies and gentlemen, it's my honor to introduce our first invited speaker, Mr. Eugene Padden, the Chief Technology Officer of Ray Business Technologies Incorporated. Your screen is yours, sir.
Thank you, Dave. Let me just start to do this one. Where they do the share the screen. Okay, here you go. Screen one. Can you see my screen?
Yes, we see your screen.
Thank you, Dave.
Your
I
side.
don't know who you were talking about in your introduction. That might be some other guy. Maing buntag, magandang umaga, buenos dias, and good morning. And it's good evening for me. I'm based in the US. And so I'm going to walk you through and based on the recap from what I've heard yesterday is that you guys are really doing, some deep discussions on AI, which makes me really glad and sad at the same time, because at my time when I was studying computer science in UST, there was really not much that we can do. We have to learn C and then that's it, or basic or Pascal. So you guys are really more advanced now. Anyway, so this morning I will talk about how we created an AI-based software as a service, and it's being deployed and available to customers worldwide, and how my team created it and what were the challenges we faced, and walk you through what it actually does. So the agenda for my talk this morning is just talking about just a short intro on AI, and then talk about our product AI Munchie, what are the features, how it works, what are the kinds of integrations that we did for it, the dashboard and reports, show you some sample screens. What were the challenges that we faced when we created this product, and what are the clear advantages? And then after that one, we'll do into Q&A session, and hopefully you guys would really come up and ask me difficult question. You can ask me any question that you want. Okay. So just a short intro on artificial intelligence. It's my understanding is that it's our way of building smart machines capable of doing tasks that imitate the traits of the human mind, like reasoning and problem solving and planning and optimal decision making, sensory perceptions. And you will see this in a lot of different applications. In transportation alone, we've seen this one in the new cars that are coming out. They have self-parking. You see that and it's like, okay, just turn it on and then it will just park on itself. When you are traveling at high speeds, you also have adaptive cruise control, wherein if the car in front of you slows down, your car also slows down without you really doing any braking. Now, in traffic light management, we also see AI being deployed here so that you can minimize the congestion. And if you haven't heard of Tesla, then they already piloted a lot of the autonomous driving. It's not fully self-driving yet, but a lot of it is like you can do hands-off. And you've seen people also just sleeping while they're riding in their cars. And this is really dangerous when they do that. But the development is there. When you talk about manufacturing, We have robots doing work in non-ergonomic conditions. You also have predictive smart maintenance. So you have a lot of machines and equipment that function. And before they break down, we have to predict as to, okay, when do we do the preventive maintenance? Same thing that you do with your car, with your motorcycle, the way we do it is like every 3,000 miles, every 5,000 miles, 5,000 kilometers, 10,000 kilometers, and sometimes it doesn't even have to do that. When you have predictive smart maintenance, you only have to pay when you think that they will break down based on historical information. And then you also get early alerts on probable quality issues. On healthcare, we've seen this one. We have very fast diagnosis using patients' health data. So you're looking at data that based on your diagnostics, and they can really give you a good idea of what's wrong with you. You also have image scanning for disease detection. So when you just do, you do MRIs before, right? But aside from that one, they just look at, I just had like a test wherein they look at my hair, they look at my fingernails, and they look at other stuff, and say like, okay, this might be something that's wrong with you because this is what we have learned in the data that we have. In finance and banking, it used to be, it's so hard to get a credit card. Now, because of artificial intelligence and the risk analysis, or somebody who can get a credit card, now it's so easy as long as you have, because before you have to show a lot of income, you have a stable job, a lot of those things. But now, like, you can't go around without a credit card, especially if you start working. And this is not only for credit cards, for loan. When you're loaning, or you're taking a loan for a car, your loan for your house, your actual interest rate is basically based on your metrics, based on how they give you a credit score, especially in the US here, they give you a credit score, and based on that one, they'll give you, some would get a higher interest rate because they were higher risk, some would get really low interest rates. And then you have automatic trading in the stock market. You don't even need somebody else. They can trade for you in split seconds or milliseconds, and they're spending a lot because that window is so much that whatever they spend, they also do make money in just milliseconds. From human resources, AI assisted recruitment, you will see this, especially in the US. You submit your resume. What happens is that it does a screening automatically whether you will be even getting into the first review of somebody. Before it gets to somebody human, it has been screened already by AI and say, okay, this is a probable fit. This one is not a good fit. Just throw them away. Okay. You can also predict attrition of employees. So you will see, if you really set it up properly, you will know which employees will eventually go at what point in their time. And that gives you an early warning that you can preempt before they leave. On agriculture, there's a lot here. You were talking about the eggplants earlier, but in the US, they're actually looking at weather patterns. They're looking at the topography and then the satellite mapping, and they see the pictures, and they actually do targeted either on watering or pesticides or even the fertilizer. So they can do all of those things so that you don't just do a blanket execution. So you save a lot on doing that. You also do monitoring of crop and soil condition, and even in my yard, it's not even agriculture, in my yard. So we used to water our garden or yard twice a week, right? But I have a machine it has a detector that says, okay, it rained yesterday, it rained the other day, and then it will say, okay, no need for you to water this week, maybe 2 days, 3 days after, because your soil is still good. So, and there's a lot, e-commerce and devices, and one way or another, you might not know it, you are using AI every day now. You cannot get away from AI. Every time that you search on Google, that's AI there. Every time that you go on Facebook, what happens, what comes out in your feed, it's driven by AI. Once you go and browse Tinder, and then you swipe left or swipe right, there's AI somewhere there. If you use Grindr, sorry, it's the same thing, right? So whatever application you're using, TikTok, how does it do all of those animations for you and determine, okay, where do you look? There's AI involved there. So in every aspect of what you're doing, aspect of your life now, AI is a major part, whether you know or you do it or not, okay? Now, in the context of how we're doing it is that from our end, we're helping businesses, and we can boost based on AI alone. It doesn't matter whether you use our product or any AI, any company that adopts AI can boost productivity by up to 40%. Just take an example. You receive your email, right? How many spams do you get a day? Spam email. Those were one of the first consumer AI that we just take for granted. Spam detection is based on AI. And it just grows and grows. So by that alone, the productivity increases for you. Now implement that across all of your different business processes. That's how important and powerful it is. Now, you guys who are studying AI now, you are in great demand because you will be contributing to about 15.7 trillion. 15.7 trillion, not million, not billion. I don't even know how many zeros come after 15 when you do trillions, right? And but that's in 7 years. So by the time that you graduate, the ones who are studying now in AI, if you haven't decided yet, hey, it used to be computer science, right? You want to do computer science? That was my time. Greg and I, you said, we'll do computer science. Now it's like, just as basic, let's go into AI and like, make so much more money, right? So Randy, that was our time. It's so great to be young, okay? We're still young at heart. So that's just AI in short. So if you haven't decided yet whether you want to pursue and dedicate your life to using AI or be part of the AI industry, that's your biggest motivation there. I'll settle for the 0.7. Okay, you can go and share the 15 trillion among yourselves. Okay, so let me introduce AI Munchie and why do we call it AI Munchie? So basically, it's a Munchie is supposed to be a V-share. If you play Persian games a Munchie is somebody who is trusted, who was a confidant. He's like the consultant for you. So what we did with AI Munchie is that it's an intelligent data extraction, and it can help you save costs on overpayments and financial misreporting. Give you an example. We have a client who processes 140,000 invoices, more than 140,000 invoices a month. Just imagine you receive the invoice and then you need to type it into your system, right? That's just basic data encoding. How long would it take you to encode an invoice? Maybe like 5 to 10 minutes. How many people do you need to do 140,000 invoices a month? After like my 10 fingers, I just forgot. Sige, never mind. It just needs a lot more people. So what does it do? It scans data from your documents, whether it's a PDF, whether it's an image, and then it uses AI to identify patterns and then extracts that structured data for human or machine consumption. So once we have the structured data, just take an invoice. So you have the vendor, you have the customer, you have the invoice date. Some of you might not be familiar with this one. Just basically take your receipt, okay? When you buy something from SM, or you eat Chicken Joy, or you eat in Jollibee, or eat at McDonald's, and you see your receipt, and imagine if you have to input that manually. Those are the items that we extract, okay? Now, what we do is that also extract only the relevant data as defined by the user. So we can extract like more than 40 variables. But if you don't need all of the 40 variables, you can just define, I just need like 10 or 20 of those, and those are the things that are relevant for me. Now, when we extract the data, we also provide a confidence level. We can say, hey, this is 80% accurate, this is 90% accurate, this is 100% accurate. And that is very critical because you're looking at relevant information. It's not like when you're doing OCR, like an E might appear like a number 3, that's okay. But here, if it's a 3, if it's 30 and then you just showed 3, then that's wrong. If it's 30 and you put in 300, then that has major impact on a lot of things. What it can also do, it is language agnostic. It doesn't matter whether it's done in Arabic, whether it's in English, whether it's done in any other, in Chinese. It doesn't matter. It should be able to do that because it's learning. You just train it and then it works, and also works in different currencies, whether you're doing it in Philippine peso, Australian dollar, US dollar, Canadian dollar, European euro. Okay, so it's not. And then the other thing that we really did is made it cloud native because of all one is that for reach, how do we get to our customers faster? It has to be on the cloud. How do we scale? Because AI, as you know, takes up a lot of resources, especially on the training side. The execution or the evaluation for a model. So you have your sample data and you train it. It takes so much time, takes so much resources, right? But once you have the model and then just run your data that you want to evaluate, it will be so fast. So you actually have a lot of requirements to do that from a data model training side. But that's only the AI portion. And that's why I wanted to talk to you guys, is that it's not enough for you to look at the AI portion of it, but how do you actually create a product that wraps around it? And the challenges that we put in here is really, how do we make that happen? Because you have all of these great ideas. Where do you go from there? How do I collect data? How do I collect payment, right, from my customers? How do I authenticate? Where do I store? So those are all of the challenges that we went through and then figured out, okay, this is how we're going to do it. All right, so some of the key things that we look at is that we can extract all of the data and then pass it into an ERP. An ERP is like an enterprise resource planning system. It might be something like Dynamics 365, it's SAP, could be Salesforce, but I don't see Salesforce more on the ERP side. And then looking at a zero downtime with accurate data extraction. So when you're deploying something that's for global consumption, and we just had a downtime for Facebook, right? How many hours? 2-3 hours. I did not even notice it. Like it's not that important to me at that time. But for so many people who are making money out of their Facebook presence, that is significant. And that's already Facebook. And we do make mistakes. That's given, right? But we just have to strive for and target zero downtime. If we miss it, we miss by a few seconds. Okay. We do a lot of validation. So we look at end-to-end process from a PO to invoice to book processing. We can identify duplicate data. So if you have already received the invoice and then somebody sends the invoice, your vendor tries to bill you twice, then you'll be able to flag that. Okay. Then you can also price check. So if you said, oh, I bought this for $10, 100 pesos, and then your vendor tries to charge you 120 pesos, like, oh, hey, imagine the manual intervention that you have to do. For every invoice that you receive, you look at it, is it 100? I look at the purchase order, is it 100? And then you have an invoice that has like 100 items that you need to check. So how long does it take? Never mind. It's going to be a long process, and that is very, very mistake prone. And that's what we have eliminated. It's not only faster, but it is more accurate and minimizes errors. Okay. So we also have added business rules, and we know that globally we have different ways of collecting taxes like GST, VAT. So GST, I think some other countries you have VAT. In the US, it's a bit different. And then we also have to look at country-specific data regulation and compliance. So some countries would not allow data to get out of their country, right? So if you are looking at financial data, if you are in the Philippines, you just want to keep it in the Philippines. If it goes somewhere else, then you are, they would think that, okay, legally somebody can subpoena you and they can get your information. Now, if you are doing something illegal, then you would be worried. If you're not doing something illegal, you should still be worried, because you will never know. Somebody will go after your data, whether you know it or not. Okay. And then we have different modes of how we receive data. So we can receive data via email. You can use our APIs. You can do it at FTP server, or you can upload through our dashboard. Also, we have built-in integrations with some ERP software like Dynamics 365, QuickBooks, MyOB in Australia. And then we also have an approval process so that only people who have access to that data can get it. And we also do accounts notification in case an issue with an invoice. In just an example, if we receive a data invoice and then we process it and it says like, hey, it's less than your threshold. So you actually define the threshold of what passes. If say only 95% you send to ERP, anything less than 95% confidence level, let's flag it and then we'll work on it. So basically the workflow for us is that if it's below your confidence level, you can submit that document for training. so that on the next training run, and we do training every day. So on the next training run, your document will be included, and then it will automatically be reprocessed, and then it will get, hopefully it will pass, but most definitely it will pass. Okay. So just a basic flow of what, just for show of a diagram and visualization is that you can have a PNG, a JPEG, a PDF, a Word document, a text file, whatever it is that your input, and we push it into our cloud environment. So right now we're using Azure. We also use Google Cloud, and we can run it on AWS. And we run it through our AI model, and we have different models. So it's not only for one document, and even for a particular document, we have different models. So there's a different model for the US, there's a different model for Europe, there's a different model for Asia Pacific as well. It depends on where it's relevant, and we can, and it's so, because we've created it to be agnostic to that, we can just basically, we're just subdividing the models so that it becomes context sensitive for you. And then from an output format, we can do CSV, JSON, or just a regular text file. And from a user consumption, we can send it to SQL, your ERP, or Dynamics 365. Basically end to end. Most of the time, we only focus on this side. All the research, the R&D that we do is on here. But how do you create a product for that? It's not. It might be, even when you do it for your corporation, the next question is that, hey, how do I use your system? And then I don't know, right? So you open a Jupyter notebook and then just run it, and then, hey, I have job security. Anything you need, just come to me, and then I'll do it for you. That works for 1 or 2 users, but for you to scale, you have to create a wrapper around it. Okay. So just walk you through, like, this is a simple animation. So you have the invoice. This is some things that we get, company name, summary description. And I use the invoice as an example, but it's not really just limited to invoices, because we have defined it to be document agnostic. We just figured out that the go-to market for us is address a need that a lot of companies have for manual processing. Okay. So you have, I don't know if you're familiar with business process outsourcing, wherein we have a lot of I don't call them call centers, but outsourcing in the Philippines, wherein they do this one, the back office, right? So they do this, they manually do this one, and imagine if you are able to introduce this one. Okay. So we pay that, we extract. This is just basically 12, but we extract more than 40 different variables, and we also extract line items. So if you have so if you just imagine if you ordered in Jollibee and you got Chicken Joy, and then you had what's this, peach mango pie, and then you have a Coke, and then you have fries. Each one of those items will be extracted. How many did you get? What was the unit price? If there is a tax, we will include, and we will get all of those information. Okay. Now, just another way of looking at it is that you send us an email. So basically, when you register to the system, there's a known email address for you. So whenever we receive an email from that address, we process it, and then we route it into your model. So each of you, when you sign up, when you use AI Munchie, you actually create your model first and define, hey, which model would I want to use, and which fields are relevant for me. And once I have that, you can basically just send data to it. You can have your own FTP server. You set up your FTP connections, or you can use our API, and our API uses Azure Active Directory, and basically uses authentication there that is also secure. So in that case, it uses JW tokens. So again, we're not reinventing the wheel. We're just basically putting things together. And what we made sure is that this portion is the one that is like our secret sauce, right? Or you can actually upload it to the dashboard. And then after we process, so we do a lot of backend process here. We can do scaling. We're doing message queuing. We're using Kubernetes clusters, a lot of the cool stuff that works. And then it just spews out a JSON output. So we can send it to your email address that you want to receive it to, or if you have an FTP server, we send it to you. If you want, you can also read our API and say, hey, are there new messages to us? And then yeah, we send it to you. Or if you have external APIs, we can also send it to your APIs. So basically, it's just we're simplifying it, but it's really, I would say it's simple if you know what you're doing. it's difficult if you really don't know what you're doing. So yeah, just to show you the dashboard and metrics that we have. So here, this portion is when you're creating your tenant AI model. So what kind of model are you using, and what are the fields that are relevant to you? And if you'll notice, there's a weight on how important that field is. So if you're extracting every field and say the weight is 10, so we score that based on that. So if there are 10 fields and then 10 weight for each, so it's 10 times 10, that's 100, right? But you just multiply that whatever you want. And then if say, some fields are not really not important, but I still would like you to extract it. So basically, yeah, we let you do that. And here you will see it's required or not. So if we are able to extract it, then it should be there. If it's not there, then it failed. It's just basically straight out, it failed. We will still give you the data, but then you can just submit it for reprocessing. Okay, and then you can have multiple users, different roles, and then once you have, give you an example here. This is an actual invoice. Once you have extracted it, you can actually review what are the header and the details that you can go from it. So we're displaying to you the actual document and then the result of the extraction for that document. You don't have to do this. Okay, if you just want to check once in a while, yeah, you can do this. But theoretically, once this is extracted, it just gets pushed into your ERP or other system. Okay, and then you just have a list of the different documents. See here, example, just a list of the different documents, and you have the status, whether it's already completed, it has been submitted, and whether it has failed. So other things that and when it was submitted, and what's the confidence level. Okay, and then a report is a summary of how many documents did you process for the day, how many were successful, how many were failed, how many did you submit for training. So basically just wrapping it all up. And this is very simple dashboard and analytics, but again, it just gives you a feel of what you should be looking at, and you can extend it some more, right, as you go along. But what other document types? You were talking only about invoices, but what other things you can do? So we can look at purchase orders as well. We can look at ID cards. So example, if you have a driver's license, so there are still some agencies or some companies that will require you to submit your driver's license, whether it's a scanned copy or a picture of it. When you apply for insurance, when you apply for car insurance, life insurance, you still submit and have to write a lot of documents, right? So you have to fill up the documents, still not online. And even if you do it online, what do? They create a file out of it, and then they store it, and then they submit it. Somebody has to do back-end process. We can take away that portion. Electric bills, water bills, bid of sale, legal agreement. So we can, it's just a matter of training the models. Which fields do we need to extract, defining that model, and then just run it through that process. Okay, so what were the challenges that we faced? First one is choosing the right model. We are extracting text data from documents, right? From PDF and images and whatever. But how do we extract that data? What model do we use? Do we use deep learning? Do you use natural language processing? Those are the things that you may have to make a decision. And this one takes trial and error and expertise and experience also. Because you will get false positives. You will say, hey, my model is really, really good. But then sometimes you might be overfitting your model. Okay. And then once you submit your test data, not there. Okay. And then sometimes architecture should be compatible on how you want to organize and manage extracted data. Some of them will be still fuzzy. Some of them you can, okay, now I can use this one. This is JSON. So there's a lot of things that you have to work through here. Once you have chosen the right model, which you still have to do, you have sample data, you might have some dummy data. Next one is gathering data. And this is what Dave was talking about when some of the speakers, right? You have to get data that is representative of what you want to process. And this is the hardest part, because in our case, we are looking at financial information, okay? We have to have people disclose to us information, and we have to have NDAs, that's the biggest challenge, okay? And then multiply that across different geographies. So we're not only looking at getting data from one country, but we're getting data from a lot of different countries, okay? Now, once you have gathered that data, how do you secure it? Okay, where are you going to store? Where are you going to store it, and how do you retrieve it? What are your governance policies? Right now, we've seen a lot of data breaches because people just have access to data and they're not concerned about how secure it is, right? Especially when you have millions, oh well, not millions, you have millions and millions and millions of data that you can work on and then just run them on the cloud and you're not securing them. And then there you go, you lose a lot. What are the data governance policies that you have for privacy? Because especially this one, these are financial data, you have to make sure. And then how much can you store and how fast can you retrieve it? So it doesn't scale, it doesn't necessarily scale well. And that's why we're designing this to be cloud native so that you can store as much data as you can and you can retrieve them as fast as you can. Now, you have to marry that with your data governance. How do you protect that data? You have to be very careful, okay? No matter what it is, security is sometimes that we just take for granted, but as custodians of very important data, especially if you're looking at from a national perspective, you're looking at the government might give you some data to work with, right? It might be all of the voters, it might be all of the registered drivers, or it might be something else. That data is very important. Just access to the data is something that you have to really worry about. And now, once you have that, you have to look at data quality. Once you're training the model with text documents based out of images and PDFs, that's how good is the quality? Is there, so imagine you have that image or you have that PDF. First is you have to determine if there is a text, okay? You have to detect it, and then you have to localize it, and then you have to recognize it. That's a lot of steps. In the human mind, that's simple, that's easy. If it reads Greek to me, it's Greek to me. I don't understand, I forget, right? I don't care. But this is something that we have to work with. So from an environment standpoint, when you look at the document, you have to see how complex is the scene, how many things are there in that image or in that document. If you scanned it, you have uneven lighting. So your lighting might be good in one side, it's not like perfect. When you get a PDF that's really clear and then that's electronically created and sent to you, that's fine. But if you have scanned documents, this is a big challenge. And then when you acquire the images, there's blurring, there's degradation, there's also perspective distortion. Imagine if you do a scan, right? Your scan is never perfectly square or rectangle or circle. There's skew on the document. And then because of that, your letters, your numbers will be skewed as well. Some of them will be the same size, some will be a smaller size. How do you account for that? Human mind, it's so easy. Just read it. Okay, I just have to go. Oh, I need more glasses. I need my glasses. Otherwise, I don't have to worry about it. And then the actual text content, there's a variation of the aspect ratio. Some of the fonts are bigger, some of the fonts are smaller. Some of them might be slanted a little bit. Some of them like even written vertically, and then different languages. So you have to look at those things. How do you account for all this variability? Your model should be able to look at this. Okay, and the more data you have, the more accurate it becomes. Now there are some other that are OCR detection. This has been the longest time. The system that we replaced was using OCR. The accuracy was only 70-75%, and not even getting the line items. It's just basically getting the vendor, the dates, and then the total. Not getting the chicken joy, not getting the getting the fries, and not getting your Coke, right? So just imagine you have ambiguous shape of letters and numbers. They are human readable. We have been trained since we were young. Teachers, right? You have trained us well to read the 3 R's: reading, writing, and arithmetic. Okay, but they are not machine readable. Machine has been like, we have seen the evolution, but it doesn't really, hasn't gone that far. That's why we need AI. And then ambiguity, especially for financial documents, is a serious concern, because if you the discussion, the example I had before, an E or a 3 visually is similar, but if you make that mistake, you're dead, right? Let's imagine your bank account, you're depositing something, and then you deposited a check. You have the reader of the check and says, okay, this is supposed to be 100,000 pesos, and then it just read like 300 pesos. So you will cry. Okay. It does yield good results, but only on very specific use cases. That's why this is like just one step. You still need a lot of massaging. Sometimes what we do is that before we do OCR detection, we do alignment. So imagine the previous one wherein there's a skewing and there's a lighting issue, there's a distortion. So we do all of that first, and then after that we can do the OCR detection. So basically, you look at the image here, we're doing the document scan, we scan it, and then we do the pre-processing, and then we do some other stuff. I don't know. My guys were the ones who did this one. I just like guide them on what needs to be done. Okay, and then the output. And then the other concern for us was the accuracy. Remember, that was my main goal for them. For every extraction, you should give me a score, because if you don't give me a score, I don't know whether you're successful or not. And that's the accuracy level. You have it in recommendation engines. Recommendation engines, after you train it, it will give you will have a sample, and then you have a control data, and then you run it with that. And it will tell you that, okay, we have trained the model and the accuracy of this model is 75%. So it will give you recommendation 75% of the time that is correct. That is fine. That's a recommendation engine. But if you're reading an invoice and you only have a 75% accuracy rate, your customer will say, never mind, don't talk to us, right? That's not where we are. We're back to OCR level. So that's the key goal. We have to have, and us AI guys, they were saying, how do I do that? It's like, you have to figure it out. That's a requirement that I need. You need to tell me how good is the extraction. So they were able to figure it out. Okay. So you have low data quality. How do you make sure you extract it properly? You have a very small training data. And this is very critical. If you have small training data, then your accuracy is really, that's why the data gathering is very important. You have to beg. You have to do a lot of things to make it happen. Okay. And then you have noise with errors and outliers. And then you have data that are not representative. That happens, and then your result is biased. You will get really, really biased results. Okay. Give you an example on this extraction. We did a POC for a client. He gave us like 5 documents. We sent them through. Out of the 5, without knowing that document first, out of the 5, 3 were 100%, 2 were at 95%. And the reason why it was 95%, because in the document, on the number, somebody put a check mark. Okay, so it was a document scanned, but then it was like a check mark on the number because somebody was manually verifying it. Okay, so once they sent it to us, they said, okay, we got confused. Remember this is human readable, but not machine readable. So we had to train it. After we train it, boom, 100% accuracy. So some of the things, and we know it works. Okay. Now the biggest portion of it's okay, you made it work. And this is my mantra, make it work, make it scale. Okay. So what if you become successful? What do you do? So that's why we made it very, very native cloud native. So we have to create a hosting environment so that users can get to it. And then it can handle processing of documents, thousands of documents per minute. So it can scale up, it can scale down. You also have to manage your costs. So this is one of the key challenges for us. How do we make it? So my mantra, and I've told Greg this, make it work, make it scale, make it maintainable, make it secure, right? And if you make those happen, you're in a good place. Okay. The fifth one is make money, but that should be somewhere down the road. Okay.
It should follow.
It will follow. Okay, what were the advantages? High accuracy, we can process thousands of documents per hour without 99% without human intervention. The 1% is when we do get the failure, and we just have to basically review, and it's submitted to us, and we review why it failed, and we need to just make it part of the next training. Really good process efficiency. Imagine how many, it's like it takes 10 minutes. Just imagine if it takes you 10 minutes to process one document, it takes a few seconds for us to do it. And then we have the scaling, and we can even do prediction of missing data. So if there's a missing data, we can say, okay, this might be the missing data, and this is how we're going to fill it out. It's available on the cloud as a SaaS platform, software as a service, or it can be done on premise, but we would recommend to do it on the cloud. We can process any document format, images, PDF, handwriting. The handwriting, it just has to, you have to train more. It becomes very tricky. But just imagine the US Postal Service invested millions of how to recognize handwriting, just the zip code. So they have a sorter for mail, and we do have a lot of mail, right? So basically it scans through the mail, and then it will read the zip code where it's going to be sent. And that's basically how it's routed. And they spent a lot of that just to make sure that. But imagine millions of mail a day. How do you sort? Which one goes to Cebu? Which one goes to? You have mail sorters there, right, Greg or Dave?
Physical
You have
mail
somebody who
sorter.
Yeah. That's why mail takes 3 days,
Yeah.
and that's transport. But routing, it's so much easier. We've seen productivity by at least 72%, and then we have, again, I tell you, we have a client that processes about 140,000 invoices per month. 100. Imagine how many people, like more than 300 to 500 people that you have to hire. And they can be redeployed to do more meaningful tasks. I'm not saying take them out, right? And what I'm saying is that they can do more meaningful tasks, because this is something that can easily be automated and you don't have to really do much for it. Okay. All right. So basically we're on the Q&A. I hope I did not go over time. So the first question is that, yes, we're hiring. Okay, that's it.
Yeah. Thank you, sir. And yeah, we are actually on time, 5 minutes before 10 o'clock as per program. I would like to ask the participants, if you have questions, you can actually type in your questions at the Q&A box or button in your Zoom screen found on the bottom part of your screen. Feel free to ask, or you can also raise your hand if you like, and I think we can give you the screen, and I think we can let you talk if you
You
like
can
to.
ask in Bisaya, you can ask in Tagalog, you
Yes,
can ask in English, maybe a little bit Spanish. Okay.
yes.
For Chinese, Eugene.
And
Unfortunately, I haven't
Chinese.
gone through that one yet. I have Chinese blood, but no.
I thought you were Chinese because your family name is Canton. A
Yes,
middle name. Canton, as in
my
Canton.
my
Yeah.
great grandfather came from China. Yes.
Okay.
Mm,
Okay.
yeah. So while waiting for the question, sir, I was um, listening. While listening, I was thinking of if I am a fresh graduate, what key skills should I need to work in your company?
So it starts with values.
Yeah.
So Greg, I've told this one. Value for you is that, one, you have to communicate properly. Okay. So you have to start listening. Don't, and sometimes that's just a tendency. When we ask people, um, what do you mean by communication? What's your understanding of communication? The first answer they will say is that to be understood. And that is the second part of it. The first thing is you have to understand first, and then you can be understood. So, because everything stems from there. Doesn't matter how good you are, if you don't listen, what happens? Not much, right? So that's one. The second one is that you have to be proactive. So, and proactive is just basically, I don't have to tell you everything. You know what the goals are, you know what needs to be achieved, and go and do your work, do your part. You can ask questions, and part of it is just basically, if you don't know what it is, ask the question and do your work. That's it. And then the third one is always strive for excellence. Okay. And when I say, and I ask people what is excellence, the answer is that doing my best. That is not excellent. That is doing your best. But I give the example, I will do my best to play basketball, but I will definitely suck every time, right? Because I'm too short. I will never be excellent in basketball in that case, no matter how I practice. So basically, excellence is doing things the best that you can do them. And then the fourth one is being customer focused. Really look at what do people need. And that's where, as Filipinos, we are a service-oriented people, right? We are very, what's this? Hospitable. Sometimes we give more than what we have. And It might be good, it might be bad, but that's a key foundation of how you become successful. You are always looking for what's best for others. After that, things will come to you. You know, those are just the key strategies. See, I never even talked about technical skills, right?
Yeah.
Because you guys are taking care of that. You're the teachers. You're taking care of the technical skills. So
Thank you.
it's
That's
more about behavior.
yeah, that's
Actually, Eugene is
very
also a life coach. Okay. So during our weekly meeting, we don't talk much. We're the ones talking something technical, but Eugene is the one talking like more in the behavioral. In fact, he's even more of a teacher than me.
Okay, so let me. We have two questions. So one is from
Yeah.
Maria Rodelin Tibon, and her question is: Do hardware matter? Does hardware matter? And what are your tips in the minimum hardware requirements to train the model? And this is very key, because if I ask you to train the model and you're really using a very powerful model, it will be so hard for you to get your own individual hardware. To get just even to get it. So I just bought an NVIDIA RTX 3070. I waited like almost a year just to get it, to be able to run AI and ML on my local machine. Why go through the trouble? You can use the cloud, and that's what we did. We rented virtual machines that have GPU capabilities that are designed for AI, and it does matter, because yeah, you can train your model and it takes you 3 days, or you can train your model and it takes you minutes. And that's one of the key things that we look at, is how do we scale that training? Because if your training takes you several hours, by the time you're done, it might not be relevant. Okay, so I hope that answers your question. Yes, it does matter, hardware. For Ferdy, he's asking, price is now $199, and is it full package or basic premium? And so basically the pricing that we have is based on the number of documents that you process on a monthly basis. So there's a minimum threshold. So you start for smaller companies and you say like lower value. So if you process like maybe 100 documents, 100 invoices. So we designed this one for small businesses and large enterprises. So if you are a small company, you have maybe 2 or 3 people, and you do get 5 or 10 invoices, then you can do it manually, right? But once you get into 100 invoices a month, then that's like one full-time person that you have to hire just for that, or you can outsource it to somebody else. So we have it something like $25 or $50 for that. So it's not much. It's less than the cost of paying for a full-time employee to do it for you. So it's based on the number of documents. If you do exceed, there's just an overage for it. So that's how we design it. From Festijo, in your current implementation, how do you ensure confidentiality, privacy of the data? And that's why we're using the cloud here. So basically what we do is that for every customer, we instantiate a separate database for them. So that's one. So there's no commingling and co-mixing of data for one customer to another customer. So we're already separating that. The second one is that we put it in the data center that is closest to the customer. So if the customer is in the US, the data is all in the US. If you are in the Philippines, but we don't have a data center in the Philippines, then we store it closest to you, which is Singapore. Okay. A second one. The third one is that all of these things are done via keys and being encrypted. So basically we don't have, it's encrypted at rest. So we don't, if somebody picks it up, if they don't have the keys, then they won't be able to see it. The third one is that the only guys who have access to the actual data is basically not much, like 2 or 3 people that has access to it. Because everything else, they just have a proxy that gets to retrieve that, and they just see the reports. They don't have access to the actual data. And to even make it further secure is that you can store it in your own data store. So remember I talked to you about storing it in your FTP server. So basically what you do is that put it in your FTP server, we read it, we extract it, and then we send it back to your FTP server. So it only stays in our servers a short period of time, and then it gets destroyed and then sends back to you the result. That's it. We're not doing that. So you can use FTP. Now we also have integrated with Dropbox. So if you want it to be stored in Dropbox, you can do that as well. Okay.
okay.
Ferdy, there's one more. Ferdy, can I be
yeah.
employed and hire me even though I'm here in the Philippines? We already have a company in the Philippines. We have about 5 guys now working there, and we're hiring.
Okay. Okay, and I think one last question here on the chat box. Do you
Yeah.
accept remote internship if in case considering of the flexible learning mode limited face to face right now?
Yep. And that's one of the key things. That's why I'm excited, because I grew up in the Philippines, right? Well, I did not grow tall, but that's when I grew older. And I want to give back also. It's part of it. It's like I owe a lot where I grew up in. I was born in Mindanao. I was born in Davao. I studied elementary and high school in Cebu, and then I graduated from college and worked in Manila for a longer time. So
Thank
it's
you for that information, sir. And I think our participants are taking screenshots already or contact information, especially perhaps for our administrators, having a problem of sending off their internship OJT, especially of this, um, not able to meet physical classes. So thank you very much. In this juncture, if you have further questions, I think you have there the all social media connections. You can approach Sir Eugene if you have further questions, and perhaps Greg also can help you out
Yeah.
if for the
Greg can
Philippines.
help you out. So our goal is really to have,
Yeah.
because some of the things that we're working, just imagine we're doing a lot of, it's not being done commonly in the Philippines, right? So if you want to go and learn these things, it will be so hard for you. You will be starting from scratch, and you don't want to do that. You want to go and do it with somebody who has done it before. And that was my challenge before, because the internet was not as prevalent. I was just lucky that when I was with ABS-CBN, we had fast access to internet, and we were one of the first ones to have it. So I was able to deploy a lot of these new technologies faster than anyone else. But after that, it became like, okay, it's not access anymore. It's basically knowledge and who has expertise. And that's the beauty of the internet now. You can have access to any of these guys. It's not only limited to us. It's just about anyone else.
Okay. Thank you very much. I think we have a lot of things learned from the discussion. Let's be proactive, let's strive excellence, and let's be customer focused. So in this juncture, we would like to present our certificate of appreciation for recognizing Sir Eugene for sharing his valuable time and expertise as a presenter for the activity Fourth Computing Society of the Philippines Special Interest Group on Information, Communication, Education e-conference. Sir, we hope to see you in person, at not necessarily at Siliman, but perhaps in USJR on in some other
Yeah.
avenue, perhaps next year.
Yeah,
In
I,
our,
Next
we are
year, next year,
hoping.
Eugene, we're going to have ICE conference either in Baguio or in Boracay, or probably in the one down south. What's that
anywhere is
date
okay.
again?
Anywhere is okay.
Uh,
Thank you so much. Thank you so much. Thank you, sir.
Thank you.
Let me proceed to our second
Thank you, Eugene.
second invited speaker. I think our second invited speaker is, I think, not new to us. Been a suki to CSP, and I think um, I should just proceed reading the biodata. Our next invited speaker is the Chief Analytics Officer of Cobena Business Analytics and Strategy, a demand science group company. Previously, Dean of the College of Computer Studies and Professor of Computer Science at Ateneo Dinaga University. Awarded as Outstanding Young Scientist in 2010 by the National Academy of Science and Technology. Our speaker for this morning has BS in Mathematics and Master of Science in Computer Science from Ateneo de Manila University, and got his PhD in Computer Science from Virginia Technology. Published peer-reviewed academic papers in Index Scientific journals. Friends, one of the core leader and perhaps haligi din ng CSP. Let's welcome Dr. Alan Shoson.
Thank you for that, Dave. Yeah, it's really good to be speaking again with with colleagues here. It's been a long time since I was in the academy. Ayan. So, kumusta naman, Bay?
Okay naman, okay naman. Okay sa Siliman, okay sa Dumaguete. We're still on online.
That's right. I've been wondering how teachers nowadays are teaching, especially because of the situation now that all of us are forced to adopt a different mode of teaching. And in fact, I've been wondering myself, if I am still a teacher, how would I teach programming? how can I check whether my students are actually learning? So it's really a challenge, especially now. But I think amongst the programs, I think computer science, IT, IS programs are very much ready for this kind of say arrangement, say online teaching, and they now call it what's this, synchronous and asynchronous mode of instruction,
and hybrid.
A hybrid, that's
blended.
Right. So thank you. I'll share my screen now.
Please go ahead.
Do you see my screen now?
Not
is it showing?
Not showing.
Let me do it again.
We're just seeing your face.
See, I don't know how to do this.
At least you have an excuse now to do it again.
Open system preferences. Why is it not showing up?
You have two screens. It's a Zoom. You can actually select the two screens.
So it's not yet showing up, right?
Not yet.
Why is my let me do this. Greg, I'll send you the PDF of my presentation so that or anyone.
Yeah, that's possible.
I'll do that.
I'll wait for it, and then I'll share it to the technical team, sila Jovil and Francis. Okay lang, Francis and Jovil?
Yes, sir. We will facilitate.
Thank you very much.
Yeah, I'm having a hard time sharing my screen.
Are you using Mac?
Yes.
Yeah, that's a problem.
I'm sorry.
Okay, so okay, for a moment. I'm actually forwarding it to our group, Jovil and Francis. You should be getting it. Okay, so let's have a bit of interviewing Alan by Dave. Let's get to know him more while we're preparing the slide. So, how's everything in Cubina, Doc Alan? You're so busy, so meaning financially, it's in abundance.
No, we have to pivot. This and this. Cubina is a management consulting company, so we thrive when when companies would want our services. But because of the pandemic, demand for consultancy actually went down, and we have to pivot. Currently, Cobina has been acquired by Demand Science Global, and we're basically part of a global company now. And most of our work has been related to development of systems or platforms for the US market. So that's what we are doing now. And we're kind of adjusting, because most of the work now are not just in Philippine time, but we have most of our meetings now are done in the evenings, because that's morning in the US, evening with us. Ayan. Thank you.
Okay.
So I entitled this talk as on the practice of data science. I'd like to give perspective on my experience as a practitioner of data science in the industry. At the same time, kind of contrast it with the way I taught before as a teacher of computer science. So I hope you guys will be able to appreciate this sharing. Okay, next slide, please. Okay, so this is Johannes Gutenberg. He's the inventor of the movable type in 1439. Yeah. And that is an early wooden printing press that produces, say, 240 impressions per hour. During that time, that is actually an amazing invention. Now, in around 2004, if I'm not mistaken, Google started this advocacy or mission to scan all the books in the world, all the published books in the world. And by around 2017, if I'm not mistaken, Google was able to scan approximately around 30 million books over the published, over books I've ever published, which is roughly 20% of all books ever published. That is according to Steven Schiena. I've taken this quote from his book published in 2017. At the right-hand side, that's a result. That's a Google result of my query. When I queried Google's mission to digitize our world's published books, and that's the result. And you see that while Google has this mission, there has been challenges, in particular copyright issues. Google has been stopped from scanning books in several economic in several countries. But there are also areas wherein Google is encouraged to scan all the books ever published in that area. For example, the city of Antwerp. So, in this case, this is actually an amazing feat. Imagine scanning 20 million books, and there are a lot of things that you can do with that. You can do analytics on the information contained in all those books. Could you please move to the next slide, please? Okay, this is the Google Ngram viewer. I typically use this just for fun. You may want to visit this website every now and then. Just check what are the terms that are popularly being published nowadays. For example, in this particular graph, I queried data science, computer science, information technology, big data, information systems, and this is the result. This is really a graph of the relative frequency of mentions of those terms. For example, computer science, the mention of computer science in books peaked around in early 2000, around 2003 perhaps. And then if you look at it, information systems has been very popular also even in the late 90s. And information technology is is newer than computer science and information systems. And mention of information technology peaked around this at the same time that computer science also peaked. That is early 2000. And notice that mentions of big data and mentions of data science is actually started around 2010, and it's actually slowly going up. The percentage of mentions of big data and data science relative mention is similar to the amount or the relative frequency of mention during of computer science during the late 50s and early 60s. So that's you can see that the big data data science is actually beginning to become popular. Next slide, please. I also added statistics in the mix, and notice that statistics, the mention of statistics, peaked around 1980s, and it's slowly going down. Perhaps I'm just theorizing that statistics actually being replaced by data science, and that's actually I think there's a basis for that, because most of the methods in data science can actually be traced from statistics. Next slide, please. This is Richard Hamming. If you still remember Hamming code, this is the guy. He's the one who invented that technique. The technique of finding out where the error bits are given a sequence of bits. When Richard Hamming published his result, it's actually a revolutionary idea, and a lot has been invested in that research area, and we find his ideas being implemented in a lot of error correcting mechanisms in a lot of devices that we use today. So if Richard Hamming did not start that research, we may a different person may have found a different way of doing error correcting. But one thing that I like about Richard Hamming is that he said this is actually his philosophy. The purpose of computing is insights, not numbers. So, and I actually adhere to that mantra, in a sense that at the end of the day, it's the insights that matter, not the numbers. Okay. Next slide, please. In this slide, I tried to differentiate computer science from the physical sciences. Physical sciences, I mean chemistry, physics, biology, and all the physical sciences. Now, they're quite in opposites, at least based on what I read and based on my experience. Now, when we teach computer science, we typically focus on the methods, meaning remember, I'm sure when teachers here started teaching algorithms. One of the first set of algorithms being taught are the sorting algorithms: insert sort, selection sort, merge sort, quick sort, and we discuss which one is efficient. We say that merge sort is n log n. Quick sort at best is n log n, but at worst is n squared. Now these things, we instill these ideas in our students, in the sense that we are saying that the methods are king. Whenever we test these methods, what do? We generate random numbers and then subject them to the sorting methods, and then we get the result. We don't really care about the data. We care about the efficiency of the methods. We care about the efficiency of the algorithms. A computer scientist typically invents algorithms. That's what computer science are really good at. They devote time to think how computations can be done efficiently. In fact, we also delve in research of, say, problems that cannot be computed, at least nowadays, at least with the present methods that we know, problems that cannot be computed efficiently. These are the classes of, say, NP complete, say problems. And we often think about methods, not real data. And in fact, we are defensive when we are confronted with errors. Our defense is what? Garbage in, garbage out. It is just a way of saying that, that's not my job. My job is to make things efficient. And we also care about the numbers. Typically, we are happy, whenever we have results, we are happy in, expressing the numerical equivalent, say, for example, of 5/21 to as many digits as possible. We are happy. We want to show that we can do that. But physical scientists, the real scientists, if I may, they are data-driven. They collect data to answer the question of interest. And they invent measuring tools. They don't invent algorithms, they invent measuring tools. For example, Galileo Galilei not invented, but he improved the spyglass that was available during his time and converted it to a device that he can use to study the heavenly bodies. The large the hadron collider was also invented. And what for? It's actually a very expensive endeavor, but they really like to know. They'd like to study, say, how particles are and what their properties are. What I'm saying is that real scientists invents measuring tools. Why? Because they'd like to measure things. They like to generate data. They devote time to think of how to get the data necessary to answer the problem that they have. And they're also comfortable with the idea that data has errors. They're unlike us. Well, you provide us with garbage. Of course, my methods will produce garbage. We are very defensive. Real scientists care about what the numbers mean. They don't care about the number of decimal digits after decimal point. They just have what's this? They just round it off, like 5/21 is 0.24. That's it. These things, in my opinion, differentiates computer science from the other sciences. Next slide, please. So how about data science? I think data science should get inspiration from computer science and the physical sciences. And I think it would be good if aspiring data scientists would do that. Data scientists should be driven by both methods and data. They should be well-versed in analytics tools and should have deep understanding of well-known methods. They should devote time to think about surrogate data, especially when the ideal data is not available or impossible to obtain. Perhaps there's this time when we were thinking of, think about movements of people in the city. It is part of one project that we have with a company. And the ideal data would be the data that Google has. For example, the traffic data that they have. But of course, we cannot get that. It is, it is behind the corporate wall. Even Grab data, that's also behind the corporate wall. We cannot get it. So we have to think of different or surrogate data that will allow us to study the movements of people. Data scientists should also be comfortable with the idea that data has errors, and they should learn how to compensate for it. They should care about the numbers. At the same time, they also have to care about what the numbers mean. They have to care about communicating the results to the stakeholders. I think in my stint as head of analytics in Cubina, these are the things that I've been instilling the employees that we have. Lack of data should not stop us from doing analytics. Of course, there are always ways to estimate the ideal data that we want. We have to look for, say, surrogate data, and that has been the case in a lot of projects that we have. Next slide, please. Students nowadays are very lucky because there are a lot of websites that will allow them to practice on. For example, computer science students, IT students, IS students who would like to improve their programming skills. There are websites that they can use to improve their programming skills. They can go to Codeforces. They can have an account at University of Valladolid's say online judge. There are even newer websites like Exercism that actually provides an avenue to teach students, to teach whoever is learning the language, to teach them how to properly test their programs, which is something that at least me, I wasn't able to emphasize much when I was teaching. Testing, unit testing. I think that is something that I should have emphasized more when I was still in the academy. But there are websites that already allows us, say, learners to improve their skills on. Even aspiring data scientists, they can use Kaggle for them to practice their skills. But these websites, they prepare the data sets for you. They prepare the problems for you. They know that there is a solution. In real life, problems, sometimes the problem is not specified well. You have to find out how to specify it well. You have to, in fact, you will also have to produce your own data set to test your methods, and you also have to clean the data sets before you can even begin doing analytics. Next slide, please. one one website that I recommend if you'd like to do say data science is the Quant Shop by Steven Siena. Actually, this website has videos. What Dr. Siena did is he recorded the journey of all his students in their pursuit to apply analytics, data science in different areas. For example, in 2014, he has this set of students. He challenged them to mimic the way judges judge or select the Miss Universe in 2014, and their students were flabbergasted because they don't know how to start. How can they sort of mimic how the judges think and how to select the Miss Universe amongst the candidates. So they started with perhaps there's something in the face. Perhaps there's something in the vital statistics. Perhaps there's something in their educational background, because answering the question Q&A is also vital in selecting the Miss Universe. So they have considered these things and they crack their heads. They were able to predict, at least using their methods, they were able to predict 50% of the top 16, meaning say 8 of the top 16 candidates. And they were hoping, at least in their methods, they were hoping that Miss USA will get the Miss Universe crown, but no, Miss USA was the first runner-up. But they're very close. and there are other case studies. I think you will enjoy them, watching them. It's actually very down to earth set of videos that will allow you appreciate well how data science can actually be done in the real world. Next slide, please. I'd like to mention some fundamentals. And these are the things that we typically emphasize on, say model quality, the quality of the models that are produced by the data analytics methods. The black box model versus interpretable models. The issue of data health and the issue of the cost of storage. Next slide, please. We start with model quality. George Edward Pelham box. He's known for I'm not sure if you have came across the Box-Cox transformation. The Box-Cox transformation is a transformation being used by statisticians to convert a data set to something that is normal-like. And it is also a way to stabilize the variance. I mean to say, it is a transformation that's being used, even in data science. It is actually a technique to make sure that all the statistical methods that we use will actually work, and then convert back the results back to the original format. He says that all models are approximations. Assumptions, whether implied or clearly stated, are never exactly true. Meaning to say, all models are wrong, but some models are useful. So the question you need to ask is not, is the model true? It never is. But is the model good enough for this particular application? This is a passage in the book that he co-wrote with Lucenio and Quinones. The title of the book is Statistical Control by Monitoring and Adjustment. It was published in 2009. The context of this is more on statistics, but it also rings true in data science, in a sense that we have to be aspiring data scientists. Aspiring data scientists must be comfortable with the idea that the data is never perfect, and the models are never perfect. But the question is whether it is useful. Is it something that we can use? Is it good enough for a particular problem at hand? So whenever aspiring data scientists would produce, say, not data models, but models that does a regression or classification or some other things. The crux of the matter is that models are never perfect, and there could be errors. I mean to say, we have to take care of the outliers being produced by the models and check whether the models are still applicable in those outliers. Next slide, please. The other issue is the black box approach, and versus having interpretable models. This has been an issue in my stint as practicing data scientist in Cubina. We have had projects wherein after producing the regression model or the, say, random forest model, we typically just present the results. And the problem with that is that whenever we are asked by the client, why is it that the results is like this and not like that? We have been in the industry for X number of years, and we haven't seen that this particular area is actually doing well compared to this area. Why are you telling me that this area should be performing better than this area when it's not in our experience? Now, you see, whenever you are confronted with that and you have a black box model, you cannot tell your client that, well, our methods show that is so, and of course it becomes a problem. So in our practice, we have shifted to a method that will allow us to explain the model. I mean to say, we have had we pivot to having models that are explainable, and so models that are more accessible to our clients. We cannot tell them, you see, this particular regression technique that we use just produce this weights and bias, and this is the result if you plug in the numbers. You cannot say that. you cannot say that. You have somehow present your model in a way that they will understand, so that they would know. And there's actually a reason for that, and that is accountability. Whenever you have presented the model, of course they are accountable to the bosses that they have. They cannot just rely on saying that, well, that's what scikit-learn say libraries produces. So it will just not hold water. You have to produce something that can be explained. This is an example of how where the debate is. If you look at the left-hand side, this is showing a method that allows to classify certain objects in the picture. Using attention maps, you see the evidence to label the picture as a Siberian husky, and the evidence to label the same picture as a transverse flute, a musical instrument, are almost the same. So if you show this to your client, you will have a hard time explaining it. I think there are cases wherein deep learning methods, deep learning methods are useful. For example, so perhaps a vision, perhaps that's where it is really good at. But if you use a black box technique to do, certain high stakes decision, for example, the one at the right. This is a system to predict arrest for any offense. You see, this involves categorizing an individual whether he's prone to doing crimes or not. And whenever a system has high stakes implications, I think models should be interpretable. In fact, even the National Privacy Commission of the Philippines has it in its the Data Privacy Law of 2012. It's actually stated there that you cannot have systems that will actually lead to certain decisions. So next slide, please. One thing that is often overlooked is data health. In our experience as consultants, most of the time our clients doesn't have a very reliable data sets, in the sense that most of the data are in disparate locations. Some of them are not updated, or the categories are not set. I mean to say, most of the time, not everyone, but most of the time, we have to intervene and do ETL. We have to do some data cleaning before we can start doing the analytics work. These are the 6 dimensions of data quality as specified by the Data Management Association of the United Kingdom. We don't have any such set of dimensions specified by the Computing Society of the Philippines, or I don't know. Perhaps we have to do something about it. But according to this association, the 6 dimensions of data quality would be accuracy, the correctness of description of measurement or measurement, the completeness of the data, data stored versus potential, consistency, the absence of deviations against a certain reference, timeliness, meaning to say when you need the data, it is there. It is available when required. Uniqueness, meaning to say the absence of duplicates, because duplicate records can actually create bias, unintended bias when you do analytics. Conformity, validity, conformity to format, of course, and then types, the range of values. Now, these are the things that has to be taken care of. Typically, companies establish a data governance, department, but there are also companies that doesn't have that because it's actually costly. It is costly to maintain a team that will make sure that the data are in order. Okay. especially if the data is being produced by different departments. Consolidating them in one data warehouse is actually a big task. But I think if you want to leverage on analytics, the 6 dimensions of equality should be taken care of. It has to be in place. Next slide, please. And also, there's this cost of keeping data. This came from a study by Blanco. Blanco is a company. I've taken this from their white paper, The High Cost of Cluttered Data Centers, published they published it online January 2019. The question here is approximately how much of your data do you store on premise in enterprise old data centers? I mean to say, how much of your data is being kept in on premise? So look at this chart. Healthcare, 10 to 30%, 31 to 60%. That's the maximum. So we need to say that the range is around 10 to 60%. Public sector, same thing. Pharmaceutical, same thing. Finance, retail, telecommunications. Meaning to say a lot of companies are still keeping data on premise, and the fear is really more on that. There's this fear of putting data on the cloud. The fear of the cloud provider being hacked and their data sets being leaked. There's this news, if I'm not mistaken, just yesterday or the other day. There's this company whose source code was leaked online. The company, the company was bought by Jeff Bezos of Amazon, but then the source code was just given for free online. Perhaps most companies are in fear of experiencing the same. But looking at the what's this that particular news item, that news, I think that the leak is actually not related to the use of cloud, because I think the source code that was put online was actually stored on premise. So doesn't really answer doesn't really address the need of the clients. Meaning to say, if you are hacked, even if your data sets are on premise, you're not really protected. It's really the data governance, all the data security measures that has to be in place for you to be able to protect your data. So it's really costly to keep data, and a lot of data sets are being kept on premise. Even there are even data sets that are kept in hard drives that are already old. Yung mga old SATA siguro. They're not yet upgraded. And data sets are just sitting in a lot of hard drives and being unused. But anyway, my point in this slide is that when you keep data, it has you have to take care of the cost, and the cost just keep on increasing. Okay, next slide, please. The last point that I'd like to make is that models and data have value. There are certain research areas that are being taken, that are being studied. For example, is it possible to share the black box model securely? Meaning to say, is it possible to do that? Because most of the models, it's really just a bunch of computing interconnections, weights, and biases. So once you get hold of that information, you can actually just get that program. You can hard code it in the program and then use the models. But is it possible to have a secure way of sharing, say, models without telling the users exactly what the components are? Is it possible to commoditize it? I'm not sure if that's good. In the same manner, is it possible to share data sets securely? Is it possible for us, aspiring data scientists, to train models on data sets that we don't even have a direct access to? I mean to say, for example, is it possible for Grab, for example, to share with us their data sets, and we train our models on that? Is that even possible? Is there a way to set up an infrastructure to do a sort of a data exchange? And then the question of how do we evaluate the information contained in the data sets? We've been told that data is the new oil. How do we evaluate? Is it really true? Is it really true that data has that enormous value? Okay. For example, the data sets, the 30 million scanned books by Google. It's just sitting somewhere in one of Google's data servers. You cannot read it, but if I'm not mistaken, they have struck an agreement that while people cannot read read the books, machines can actually, algorithms can actually process the data and use the results in research projects. I think that's what Google is doing because they cannot really share the entire book. But Ngram, for example, is a very good tool that allows you to track the mentions of different phrases. But how much value? How much is the value of those data? There are data sets that are of no value, perhaps, or little value. Perhaps there should be a way of doing valuation of the data. Is it possible to do that? Okay, so those are questions that I have in mind. I don't have answers to that. Perhaps the people here will have possible answers or probably a strategy on how to do that. In particular, the data exchange idea is actually a very good one. We've been working on such a system for quite some time now. We are building a platform to do something like that. The details are, of course, proprietary, but that is actually the idea. Is it possible to do that? And I think it's possible. Last slide, please. So I have 4 concluding remarks. The first one is that the practice of data science is influenced by computer science and the physical sciences, and I think that's a good thing. Building models and keeping relevant data has cost. As we have to recognize the cost of building models and the cost of keeping relevant data, keeping the data healthy. Models and data can be evaluated. I think we have to begin to think about this. I think the learning institutions, the universities, I think we have a role to play. We are building the data science practice, and well, Jimmy already and his team in his technical committee already built a BS data science program. We're still waiting for it to be approved and promulgated. I think we are in this together. We would like to have a better uh, ins- data science instruction and produce better data scientists in the future. This is my last slide. So thank you. If you have questions, I can accommodate those questions.
Thank you, Alan, and as usual, a very enlightening and so much to learn. And new technologies, perhaps. I'm sure also that our participants have many takeaways from you, especially on those Kaggle. I'm also using Kaggle actually to play around some data. I agree with you. The purpose of computing is insight, not just simply numbers. And I think that is true in these times, especially that we are producing a lot of data. Once again, participants, colleagues in the academy, if you have questions, just type in the Q&A. For the purposes of time, I think we have to limit our questions to 2 to 3 perhaps of the questions, while some of our participants are still typing their questions. I was about to ask this while you were sharing your slide, and to perhaps to join it with your conclusion that learning institutions have big role. If you could turn back times, because you were dean, what or give us three things that you will do if you could turn back times, being the dean and the professor in computer science in the classroom.
Yeah, perhaps if I, well, in 2017, when I was still in the academy, perhaps if I am to, create a curriculum, BS data science curriculum, I could have naively created a curriculum that is very much similar to computer science, and I think that's it. That is a mistake. That will be a very big mistake, because data science practice has different. It's actually, how do I put this? In Cubina, our employees actually came from different disciplines. We have geodetic engineers, okay. We have management engineering graduates from Ateneo. We have industrial engineering graduates from LaSalle and UP. We have computer science graduates from Ateneo de Manila. We have IT graduates from Ateneo de Naga. We have what's this? We have information systems graduates from UST. They came from different backgrounds. We even hire com arts majors from UP. And whenever we do projects, it is important to leverage on the experiences of the different individuals. Whenever we have results that doesn't really make sense, we typically discuss this in a large group and discuss it with the people. Perhaps we can provide us with better insights, because sometimes we are clouded with our own experience and biases. I was a teacher of computer science, and as I mentioned earlier, my emphasis really on methods. I remember. There's this time when students would present their project, their capstone project, and they're showing off their web application, and they're typing in garbage information in the text boxes. I often scold them. Could you please actually type a real name in that text box, because it makes the application a real application. But they still keep on doing it. Perhaps I should have done a different thing during that time. But now that I have experience in the practice of data science, I think I would emphasize more on uh, the 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 importance of insights, of asking students whether the results make sense, whether it is something that is actually helpful.
Yeah.
I think that's something that I would like, and I would like to change. If
Yeah,
I
thank you for that. Because even yesterday, our speakers also highlighted the value of communication, the value of interpretation, and the value of message relay of the
Yes,
data or of the number, and how it is important to, or the value to the organization or to the industry. You mentioned this, that cares about communicating the result to the stakeholder. Even prior, our invited speaker also mentioned about the value of communication, the value of customer focus, and etc. And it leads to being a teacher also, that it's not all about methods, perhaps. No, it's also about how we can interpret this method, making it more valuable to our stakeholders, to our customers in general.
yeah.
With this,
The
yes, please
project
go ahead.
defense are really really important.
Yes. So with that, we would like to thanks once again, Alan. Thank you for always be supportive to the academic, to the learning institution. As you said, the learning institution has a big role, and I think the industry and our partners also is part of this big role to help us in the academe. That is why this afternoon we have industry partners also who will be with us, no, during our discussion, to help and to collaborate for making data science, for making higher education institutions more valuable in the current times and more meaningful in the current time. So, Computing Science, Computing Society of the Philippines Special Interest Group of Information and Computing Education, in cooperation with Southern Latest State University, we would like to present this certificate of appreciation to Dr. Alan Shoson for sharing your invaluable time and expertise, as always, no, for this activity, the fourth Computing Society of the Philippines Special Interest Group on Information and Computing Education Virtual Conference. Signed by Dr. Jaime Caro, the CSP-ICE lead,
Nice, nice.
University of the Philippines, Diliman, and Dr. Rachel Rojas, the president of the Computing Society of the Philippines. Okay. Once again, daghang salamat, and we hope to see you. I hope you can join us this afternoon for the discussions on the BS in Data Science. Okay, so daghang salamat, bayanan.
Salamat. Thank you. Bye.
The next part of our program is the paper presentations from our participants, or during the call for paper. For this morning, or for this session, we will be hearing two paper presentations, and I think our paper presenters are now ready for their presentations. Our first presenter will present on the topic online shopping items pairing with ORB and machine learning for lowest price guarantee systems, and it will be presented by June Albert Pardillo and Teresa Bola. I would like to call the presenters to please share your presentation. Um, Sir Francis, can you elevate Sir Albert,
Okay, sir.
promote to or as panelists so that they can share? Sir Albert, are you with Therese? Okay. Okay, Sir Albert and Ma'am Therese, you both now panelists, so you can share your slide. I would like also to remind, while our first presenters are preparing, I would like to remind the second presenters for the topic real-time building instance detection using TensorFlow based on facade images for urban management. You can send us a message if you are not yet on the panelist list.
Good
I
morning.
think we are ready for our first presenter.
Good morning. We've already pre-recorded our presentation for today, and we'd appreciate it if you just watch. Thank you. Is it audible, sir?
Yes, it is audible.
Okay.
Which one? Your video? Not yet. Not yet. I think
yet.
you have.
Can't hear your audio, Bert.
Oh wait.
You are audible, but your video is not.
Have the largest
Now?
market share.
Okay.
Lazada. Okay.
Is it audible now, sir?
Online shopping has
Yes,
become a
it is.
Yes, we can hear it now.
Okay. Let's start from the beginning. Thanks.
Online shopping has become a prevalent means for people to purchase goods, especially amidst the circumstances of the global pandemic. And within the Southeast Asian markets, two sites in particular have the largest market share: Lazada and Shopee. In their efforts to better serve their customers, these sites are encouraged to improve their services by adding features that make shopping easier and more convenient. One such feature is a lowest price guarantee system, wherein the website compares prices of their products with competing websites. However, current technologies still have the trouble distinguishing whether shop listings contain similar products or not unless explicitly stated by human intervention. Most earlier lowest price guarantees are provided by customers themselves, who submit examples of a lower priced products on a competing website. As such, the problem of creating automated lowest price guarantee systems is prevalent in online shopping platforms, which is exactly what we try to tackle in our study. I am Jun Albert Pardillo, and our team aims to approach this problem through a software standpoint and use technology to autonomously match pairs of online shopping items together in order for lowest price guarantee systems to accurately compare prices among similar items. While lowest price guarantee systems already exist and are implemented on online shopping sites for a long time, they usually only compare prices with competing sites. For example, Shopee's lowest price guarantee currently compares prices of popular shop listings with the same products from Lazada and Zalora, and not within Shopee's own listings itself. As such, there is currently no system that is both autonomous and compares items within the site. In order to make this system autonomous, we will need an algorithm that pairs online shop items together in order to compare their prices. And this study, in essence, documents the process in which we try to tackle this problem, starting with a simpler method of item pairing using the Oriented Fast and Rotated Brief API, also known as ORB, which we found to be unsatisfactory, which led us to building two machine learning models utilizing rapid CUML, which ended up with a satisfactorily high success rate of around 75%. Before we further discuss the methodology, let's talk a bit more about the APIs used in this study. Oriented Fast and Rotated Brief, or ORB, is a feature detection algorithm that's been derived from the brief algorithm. It's a binary descriptor that is more rotation invariant and is resistant to noise, and is 2 orders of magnitude faster than scale invariant feature transform, or SIFT, as shown by Rubli et al. While other algorithms such as the aforementioned SIFT and another one called Speeded Up Robust Features, or SURF, are also available, we ultimately ended up using ORB due to the fact that it's free to use, which made it the most convenient one for us to utilize. As we progressed with our use of ORB, we encountered a few setbacks in its ability to pair items, which we'll discuss further later. But this led us to utilize machine learning to try and solve the problem. But training machine learning models require plenty of computational resources, which leads to long training times, especially when the model has to work with large amounts of data, leading to slow and cumbersome computation, especially when done on the CPU alone. To decrease training times, GPU acceleration is used, especially if you don't have access to tensor processing units or TPUs. GPU acceleration works by loading the data initially into the GPU, after which certain frameworks can allow computation of the data directly and lowering CPU usage. The frameworks that we use in this research is Rapids, which is a suite of open source software libraries and APIs designed for GPU accelerated ML workflows, which utilizes NVIDIA CUDA to optimize low-level computation. It was introduced in 2018 as an open source effort to support the GPU accelerated Python tool ecosystem for data science, machine learning, and scientific computing, according to Rashka et al. We decided to use Rapid CUML since it's able to distribute and accelerate the machine learning pipeline end-to-end, improving convenience on our behalf. Having said that, let's discuss the methodology for our research, starting with our dataset. We used a dataset consisting of product listings provided by Shopee. This dataset was made publicly available since Shopee was hosting a Kaggle competition creating an item pairing model and featured 32,400 products, each of which had its image, title, a predetermined grouping label with other matching products, and a perceptual hash or key hash of the image, which is essentially a fingerprint of the image which can be used to find duplicates. Our initial approach was to use orb feature detector implemented through OpenCV for matching products based solely on their images. Our initial thought was that images of the same products would ultimately contain enough similarities for the feature detector to determine matches. As such, the process was as follows. Feature descriptors for each image from the Shopee dataset directory are detected and computed using orb and stored in a list. For each set of descriptors in the list, brute force KNN matching is used to compare it with every other descriptor. After this, images with more similar feature descriptors than a given threshold of 75% are grouped together. And finally, this program outputs the set of images it considers similar. Due to the exponential nature of comparing every image feature descriptor with every other image's feature descriptors, and the limited computational resources available to us at the time of experimentation, we only cross-validated the model from the orb approach in a test set with the size of 500 product listings. After using this method, we found out that simply using feature descriptors alone didn't give us very satisfactory results, which we'll discuss later in the results and discussion section. But this led us to seek a better method for item pairing, which is why we looked into using a machine learning model. Whereas the orb method could only use image data as a basis for matching, we can also extract text data and train the model on both, giving us more insight into which product listings were in fact matches beyond simply looking similar. As we proceeded with the paper, we ended up making two data models, one which is trained on image and text data, and another improved version also trained on image and text data, but also utilizing a decision boundary to improve accuracy. For the first model, the machine learning workflow is as follows. Given the Shopee dataset, feature extraction was performed in the product images and titles. Rapids provides embedding tools for both image and text, which is what we use to extract features. For image data, the dataset already provided us with a p-hash value, which would simply be used to directly determine products with the exact same p-hash as duplicate matches. This removed some of the data points and improved some accuracy, gave us a bit more accuracy. The model was trained with image embeddings and text embeddings in separate pipelines, with the image data using k-nearest neighbors or KNN training to find similarities based on similar features, while the text data was trained using cosine similarity training. It is worth noting that we performed this training layer on both the image and text data in smaller chunks of 4096 data points at a time to make the most out of the GPU acceleration provided by Rapids and prevent memory errors. At this point, we now have a working model trained on both images and text data from the products. We performed cross-validation tests on how accurate the model was at this point based on the predetermined group labels provided by the Shopee dataset, the results of which we will discuss later. But we also added a decision boundary by comparing cosine distances between the image and text of a product using the model's cross-validation score so far. This final model, which uses a decision boundary, is considered a separate model from the previously mentioned one without it, and we conducted separate cross-validations with this model as well. Decision boundaries have long been shown to improve model accuracy as shown by Lee and Landgrave, and we'll talk about the results of these tests as well as the resulting decision boundary in the next section, which is the results in discussion. Let's first discuss the results we got from the first method, which utilized ORB. This approach relied on pairing together similar features between images, as shown here. We found that ORB was very good at pairing similarly framed images, even if said images were rotated or cropped in a different configuration, or even when the items are shifted in location as was expected from the algorithm. But what we weren't able to foresee was how it got confused with images of products in different orientations or simply images of completely dissimilar products that happen to have similar looking feature descriptors. Here we have an example of an eyebrow pencil and a package of skincare products coincidentally sharing similar feature descriptors, giving us a false positive. Likewise, images of the same product in different orientations ended up confusing ORB as well, as shown here with the telescope, which was slightly shifted in orientation. At this point, we didn't expect product images to vary as much as they did, and so the model suffered from a lot of false negatives and false positives. Also, while testing the model, we found that it was unfeasible to conduct a cross-validation test on the whole dataset. It should require exponential time to compare the feature descriptors of each image with those of every other image. So we settled for a much smaller, randomly selected test size of just 500, wherein the average CV accuracy was an underwhelming 44%. Moving on, we also have the initial machine learning model, which fared much better than the ORB's image pairing approach, compared with the one with a decision boundary. With an initial CV accuracy of 72.48% when using the training set given to us by Shopee, and a final CV accuracy of 70% when using the hidden test set, immediately we notice that it can provide more accurate matches as shown here, where the model finds matching listings of a whitening product even when the bottles are moved into different positions and with different backgrounds, since the model now takes into account the text data in similar product labels. If you also notice, the labels of each product is in Indonesian, which is because the dataset was from Shopee, which is a Southeast Asian based company. This is further improved in the final model, which utilizes a decision boundary. As mentioned earlier in the methodology, this decision boundary was created by comparing cosine distances between the text and image of a product using the initial model's CV. Shown here is a grid showing the probability that a given pair of products are a match given their image cosine distances and their text cosine distances. This data was obtained from the results of the initial model's cross-validation tests and shows that the higher the cosine product, here shown to be a whiter shade, the less likely the pair is to be a match. So with this data in mind, the decision boundary was formed by discarding product pairs with a less than 50% probability of matching based on their text and image cosine distances. By integrating this decision boundary, we managed to improve the accuracy to 75.37% in a training set and 75% in the testing set. That 5% improvement in the testing accuracy is already a significant improvement compared to the model with a decision boundary. To summarize, here's a table of the accuracies for each of the three approaches, from the ORB image only pairing approach to the machine learning image plus text model, and the machine learning model with decision boundary. It clearly shows that the machine learning models greatly outperform simply using ORB for machine pairing, with the model utilizing a decision boundary showing the greatest promise. So in conclusion, our research has created a successful autonomous way of matching online shopping items for lowest price guarantee systems to the machine learning approach using Rapid COML. This final model, which utilized Rapid COML to build a model trained on product image and title data, has a 75% accuracy and could be used by online shopping websites to provide their customers with the lowest price guarantee system for products within their own site, instead of just amongst their competitors. This research wouldn't have been possible without the help of NVIDIA's rapid COML and OpenCV's open source API, which gave us access to Orb, as well as Kaggle for hosting the Shopee product image dataset, and our research supervisor, Dr. Larmi Filoscuso. We are now open for further questions.
Thank you. And I would like to ask the audience if you have questions. Don't just type your questions at the Q&A box, and I will be reading it to our presenters. Okay, while waiting for the questions, I think just we have one. Oh no. Okay, Sir Albert. In your
Sir?
conclusion, there's a 75%, 75% accuracy. Any recommendations on how to improve, perhaps, for future researchers who will be doing the same method or strategy in order to improve the accuracy?
So one thing we did here is we created a decision boundary, and we set the discrete decision boundary to be at 50%. Perhaps future researchers could figure out whether or not 50% is the ideal or the best decision boundary to use here. Maybe they could use a machine learning approach to figure out which discrete decision boundary would give us the best accuracy. For us, we chose 50% because it made sense to, like, if it's a 50-50 chance to be either side, but perhaps there's a better percentage for that decision boundary to be that would give us a better accuracy.
I
Yes,
would
go
also
ahead,
like to
Terry.
add that there might be another way or approach on how to deal with this problem. Looking for the image embedding and the text embedding is one of the approaches to check whether the products are similar to one another. And I think that there might be another approach that will help increase the accuracy so that they will have more, so that the model can see if there are more products that are similar to each other.
Thank you very much, presenters, and good luck to your future research.
Thank you, sir.
Sir.
So let us give our certificate of appreciation to our paper presenters, Mr. June Albert Pardillo and Teres Bulabola, for presenting their paper entitled Online Shopping Items Pairing with ORB and Machine Learning for Lowest Price Guarantee Systems. Thank you very much for submitting your paper and joining us today.
Thank you as well, sir.
Thank you, sir.
Our next presenters for the paper entitled Real-Time Building Instance Detection Using TensorFlow Based on Facade Images for Urban Management. This will be presented by Thelma Palawag, Sofia Arellano, Sajiko Arumin, and Rodney Dayawin.
So, good morning to everyone. We are students from the University of the Cordilleras, Baguio City, and we are going to present our paper entitled Real-Time Building Instance Detection Using TensorFlow Based on Facade Images for Urban Management. To give an overview, these are the topics that we are going to discuss. So first, the introduction. Second, the methodology. Third, the findings, and lastly, the conclusion. Communities continue to grow and attract more people, resulting in more structures being built. Methods such as cartography or map making and geographic information systems or GIS became significant in previous recording of information and locations through different means, such as conducting census. However, the need for a more efficient method to keep an up-to-date map that can help us to improve communities as a whole is a must. With this, countries develop by taking into consideration land use with the help of proper urban planning and management for the overall improvement of society. Urban management is the process of organizing and planning communities in such a way that its programs, policies, and motives are intended to improve access to basic social needs such as jobs, improved housing, living conditions, and etc., considering the growing population.
A great example of a country that bloomed with the help of urban planning is Singapore. They were able to utilize every bit of land it had and managed to keep most of the environment, such as trees, by planning where to allocate buildings. Various types of buildings are spread among the different locations, building them vertically rather than populating them horizontally. As a result, it saved more space. Baguio City, the summer capital of the Philippines, has grown with the help of tourism and exportation of goods. Statistics shows that in 2018, the total exports of Baguio grew by 75.2% according to the Philippine Economic Zone Authority or PEZA. Boarding and housing, restaurants, businesses, retail all contributed to the development of the city, and it was expected to increase with the help of more development of the city and technological advancements. However, architecture Rafael Chan talked about how the government was not able to modernize its comprehensive land use plan, which can use more traffic problems, resulting in the inconvenience of the people.
One of the strategies of urban management is the comprehensive land use, where building type identification comes into play. Building instance detection is the process of identifying buildings according to their occupancy, using classifiers to determine if a building is residential, commercial, or others, shall help governments make use of this type of application to help urban management and planning within a community. Today, the need of efficient tracking of buildings is one of what communities lack, and the need of identifying them. With technology rapidly evolving, it has made our lives easier. Its applications are limitless, especially that the trend today is artificial intelligence, designed and trained to how humans think through complex algorithms. One type of AI is machine learning, a process wherein a computer learns based on trials or experiences, leading to constant improvement or learning of the outcome. Even deeper, machine learning can be used to solve even more complex, real-world problems through deep learning, which does not require humans to give unknown data in order to train the computer and learn.
Humans have the capability to perceive objects using the five senses. However, humans can still fail, or people have different levels of perception, and humans get tired. Thus, computers have become the extension of humans in such a way that their actions appear almost similar to humans. The senses can detect objects, so to implement it to computers, people look for ways to make it functional-like. Object detection is simply a classification problem where an item is to be identified if visible in a picture or even a video. To name a few examples are detection of road signs, roads, cars, figures such as numbers, letters, characters, and more. So with these facts presented, the main aim of our study is to develop a real-time building instance detection based on facade images using TensorFlow.
Proceeding to the methodology, there are 10 processes that were implemented to build the building type detection model, namely data acquisition, data cleaning, data augmentation, image annotation, label map preparation, TensorFlow record creation, pre-trained model installation, pipeline configuration, model training, and real-time detection. So for the first process, in retraining the model for building type detection, the first step implemented was data acquisition. This is the process where images were collected needed in retraining the model. These were acquired manually from Google Earth using snipping tool, all of which from different buildings at different locations located in Baguio City. The total collected images was 394. Afterwards, data cleaning is freeing unwanted noise within a dataset. The dataset was scanned and removed images, those covered with trees, electric posts, and those that were not captured properly. From the collected images, 394 images, the total number was reduced to 377 images.
So next was data augmentation. This is a method that may be used to multiply the quantity of training data, resulting in an improved data set. So we used horizontal flip, vertical flip, increase brightness, and zoom to create different copies of each pictures. After performing data augmentation from 377 images, it was increased to 1,404 images. Next, image annotation was done to label the augmented images individually through label IMG. This is an open source visual image annotation software used for bounding boxes and marking objects inside an image. Afterwards, label map preparation is the process of creating a text files which contains the label of the buildings of the building instances with a corresponding ID number. So next is the creation of TensorFlow record. This process of making a file that converts the annotated images from XML format into a TensorFlow readable format. So next is the pre-trained model installation, involved installing the pre-trained model from the TensorFlow repository.
Next, the pipeline configuration was the phase where the default parameters were replaced to fit the building instance detection model. In this case, 4 parameters were replaced, namely num classes, batch size, fine-tune checkpoint type, and label map path for training and testing. The model was finally trained in the model training phase in 2 approaches. First, splitting the training and testing data in a 70-30 ratio split and a 5-fold stratified k-fold cross-validation. Lastly, real-time detection is the process of preparing the model to detect building instances in real time. OpenCV was imported, then that enabled the model to detect buildings in real time. For the real-time detection, using YouTube Studio, the stream key was extracted and was combined with the stream URL. This URL was then copied and put into the device's YouTube RTMP. Then the live's URL is copied into the detection function using OpenCV.
Okay, so for our findings, the model used was the SSD MobileNet V2FP Lite 320 by 320. This was acquired from TensorFlow 2 Object Detection Zoo. It is a pre-trained model that was retrained using a custom dataset and configured parameters that enable the function of building instance detection. Next is the degree of accuracy obtained from our model came from 2 approaches. So this is the 70-30 dataset split trained with a step size of 60,000, which resulted to a 0.4 or 47% using a metric mean average precision or a MAP, which achieved almost 30% more compared to the benchmark accuracy of 20%.
The other approach was using a stratified k-fold cross-validation with 5 folds, trained with a step size of 25,000, resulting to an average of 0.38 or 38% accuracy. Between the 2 approaches, we decided to accept the first method with the 70-30 split, achieving a higher MAP of 47% compared to the stratified K-fold approach with only 38% MAP.
So we also conducted a survey to measure the extent of the usability of our model. So based on the results, the system obtained an overall score of 5.25 out of 7 and interpreted as slightly high usability. So a 7-point Likert scale used to interpret the average obtained per question. The score of 5.1 out of 7 in the usefulness suggests that the respondents find that the system has a slightly high utility service. Next, the 5.4 out of 7 average of ease of use category suggests that the respondents found our system easy to use or convenient to use. Next, the ease of learning to a 5.2 out of 7 suggests that the respondents found our system easy to learn and the flow of using the system is easy to memorize. And finally, the satisfaction 5.3 out of 7 means that the system managed to achieve the expectations of our respondents.
For the conclusion, the model was able to accurately detect building instances in real time. Despite the limits of where the data was collected, the model was able to achieve a 40% accuracy by using a 70-30 dataset split. A 70-30 split and 5-fold of stratified K-fold cross-validation were used to examine 2 strategies for splitting the data into training and testing sets. The study is limited to Baguio City. However, the findings can be applicable to other regions throughout the world. Buildings in the proximity of no-fly zones were not identified as being subject to limitations. As a result, we find that the MobileNet SST model is effective in low-quality photos obtained from freely available Google Earth Street View photographs. This research will aid in the promotion of urban development by automating manual operations, such as population mapping and urban development. The accuracy of this study might be enhanced and more features pertinent to the existing model could be added. And that concludes our presentation. Thank you for listening.
Thank you, Rodney and Sophia. I'd like to ask the audience to ask questions, clarification, comments, or perhaps suggestions to improve their paper. Yeah. The same question that I asked with the first presenter. What are your recommendations if there are other researchers who would like to continue or perhaps improve your method or improve your strategy?
One recommendation is that to increase the images used because as we have presented, we only utilize 1,000 plus of images. So maybe in the next study, they can also capture the different angles of the buildings because we only use the facade view of each building instance. So maybe they can also use the top view or side view so that more accurate. The model will detect the building more accurate.
To add to the recommendation, one suggestion that we also received was to improve the speed in detecting the images because the device that we used experienced lag when deployed real time.
Yeah, I think you can read this, Rodney. There are questions from the Q&A, but I'll just read this. Tama po ba na pre-existing model used for the same purpose pero different image dataset?
Yes, sir. There are several pre-trained model available in the TensorFlow 2 Zoo. Yeah, it's a repository in GitHub. So we select one model, pre-trained model that we can use that is suitable for us to retrain it using our own pictures or own data set.
Mm. Yeah, understandable. But I think the question focus more on how this uh, how does this method or method compare to existing and similar researches.
How this compare to existing and similar researches. So far, what we have searched or we have read, the existing researches only applies to it. It's not real time. What they have developed is not real time, so you still have to capture the picture and then you have to upload it in their model. But for us, we integrated in to OpenCV so that you can use a drone and detect the buildings in real time.
I see. I see. And what's the significance of this study? I like the question from the Q&A. What's the new insights were gained? Say, for example, anything in particular about buildings in Baguio or in the Philippines of interest?
So we have noticed that the buildings in Baguio were slightly similar. So the facade were closely similar to one another. So that didn't help much with the variation of data. So areas in the Philippines could be targeted for this type of application could be in vegan, since the building structures there are unique from restaurants, from households, and like.
Yeah, let me read the question from Ren. Should not the accuracy obtained from the more rigorous scaffold more reliable than the accuracy from the one-time 30/70 split of data?
Yes, sir.
So
Okay.
So the chosen accuracy was from the 70/30 dataset split, because when after training the k-fold validation, we noticed that after increasing the step size, the model wasn't learning anymore. So we decided to limit the training to 25,000.
Therese, do you have something to add? Sophia, sorry.
We were actually surprised to see the results that the 70/30 split data set was more, it resulted in more accuracy than the 5 k-fold that we did. So it was actually a suggestion from our advisor to do two approaches for the testing of
accuracy.
accuracy.
Was there value in retraining with new data set? Or was the pre-trained model just as effective as it is?
I don't, hindi ko gets kaano yung, sir, yung question.
Can you repeat the question?
Parang pa-elaborate pa po.
Was there value in retraining with the new data set, or was the pre-trained model just as effective?
The pre-trained model was trained by using a different data set, and its initial values, the parameters were initially trained to detect 90 classes. However, we reduced it to 9. The instances that we were target to detect. Then the batch size was reduced to 4, since the training device was only our laptops, and the specs weren't that much great.
Okay. Thank you very much, Rodney and Sophia. Congratulations for a job well done, and we hope to see more of your research output as perhaps improve more by adding more uh, looking more strategies and other methods. Once again, thank you very much, and we will be sending your certificate of appreciation for presenting your paper entitled "Real-Time Building Instance Detection Using TensorFlow Based on Facade Images for Urban Management." So once again, thank you very much, and of course, with your researchers, Dr. Telma Palawag also. Congratulations.
Yes, sir.
Thank you po, sir. Thank you po.
Thank you, everyone.
And those are our research presentations for today, though we were able to hear research output that talks about data, data sets, data science, and our first speaker mentioned about the value, the different key skills in data science. Of course, with Dr. Alan Shoson also mentioned about the value of interpretation and message relay, and that is also transpired from the presentations of our two paper presenters. So I guess that's all for this morning. For this afternoon, please come back at 1:30 or perhaps 1:15 so that we can settle, and so that at exactly 1:30 we can start our consultative forum with the Commission on Higher Education for the proposed program, and this is to be facilitated by Dr. Greg Gabison. We invited panelists from the industry and at the same time from the academe to guide us in reviewing, in looking at the different provisions of the BS in data science. That's gonna be from 1:30 to 4 o'clock in the afternoon. And of course, we before or immediately after the CHED Consultative Forum, we will be hearing also some updates, perhaps from PCAB. And I think we are very familiar with PCAB, and we are excited to learn some updates from 4 o'clock to 4:45. And we will be ending our second day session of the fourth SPICE e-conference with an announcement of or some of the activities for CSP in general. So once again, you can, I think, just stay in Zoom, or you can just leave if you are going to move out, and you can just stay. Actually, your account you can just stay, and this will not be shut off. Of course, we will be pausing our live streaming on YouTube. I continue to monitor also questions on YouTube, and I think I was able also to raise it during the Q&A portion. So once again, this is Dave Marshall, and I hope to see you this afternoon at 1:15. Thank you very much, and happy lunch, everyone.
We'll have a quick photo op by Dave.
Oh,
for
yes.
The panelists, for the panelists who are around, can you enable your videos, your camera? Then gallery view. Thank you for a moment. So who are around? Randy, where's Randy? He's the one asking, and then he's not the one coming out. Good. Okay. So I'll for a moment, let me just change views, gallery view. Okay. So 1, 2, 3, smile. Okay. For a moment, let me check. It's perfect. Okay. So I'm placing it in our group. I think we're good. And then for the participants later this afternoon, we will be sharing a copy of the draft PSG for the Bachelor of Science in Data Science. So please be around. And there are more surprises that you can expect from us, especially from Dr. Randy Gamboa. Okay, thank you and happy lunch. We'll see you later. We can pause the host. Okay, so I'm host. Stop live stream. I'll pause this